Okay, let us show how to plot this graph. I'm going to be plotting MG against Y over AO. Please, let's go to the graph to plot it. Please don't forget to share this video, like and subscribe. Now, this is the graph I'm going to use for the plotting. Let me draw my vertical line. So that is my vertical line. And let me also adjust and draw my, let me remove this cursor and draw my horizontal line. Now I have to go up a little to draw it. Please, if at this point you've not subscribed, please, I beg you, remember it's very necessary to subscribe and turn up the notification bell to have more videos when I upload them. So on the vertical and horizontal one, I'm going to write the quantity I'm plotting on the vertical axis according to the question. I'll also be casting the question on the board, and I'm also going to be writing that which I'm plotting on the horizontal, y all over AO, what I'm plotting on the horizontal, and I must put this 0, 0, 0. That is the coordinate of the origin, 0, 0. It's very important to do this. Your marks are very going to be dependent on that. And I want you to pay very rapt attention, because for a whole lot of you who are saying plotting graph is very difficult, this is going to help you. So I've decided to choose 2 cm to 20 units, and I'm going to write it at the top of the graph. 20, 40, 60, and this is 80 for every 2 cm. And remember, 2 cm means 10 small lines, or 10 lines, or 10 divisions. So let me stop at 120, but before that, let me show you the units. The scale is very important. 2 cm, this 2 cm is equivalent to, that is equivalent to 20 units on the vertical axis, or I can say on the MG axis. On the M, and that is mass in unit grams axis. So let us consider what I'm going to use as the scale. And when you consider the kind of table we have there, is very important, which is 0.1 to 0.2 cm to 0.1, 0.2. Every 2 cm is 0.1, so but they will be increasing by 0.1 until we get to where we think the highest number is. But if you look at this graph, the graph is going to be very small, and it will make me lose some marks in Y. We now want to use this because I may use, is it accuracy? I may lose some marks. So I'm going to clean it. I will retake my scale. I want it to be big. My scale has to be very big. I don't want to use. Okay, let me clean that scale. That scale will not help me. It will make my graph to be very small and very small. So I'm going to increase the scale. I'm going to say 4 cm to 0.1. Every 4 cm is going to be 0.1. So I have 0.1, 0.2, 0.3, 0.4, 0.5. At least I have scaled up the graph, even though I don't think it's up to 0.6, but we are stopping at 0.6. So this is what I'm going to be plotting on the horizontal axis. To me, is better. I use that one. So 4 cm, look at the scale, is equivalent to, it's very important to write the scale. If you don't write the scale, you are losing some marks. I think about 1 mark or 2. So you need to write the scale you are choosing. So let's keep going. Now, after choosing my scale, writing on the vertical, horizontal axis, all these, remember all the things I've written, 1, 2, 3, 4, 5, 6. I am going to do the most important thing about graph. Now pay attention. Look at what I'm saying. On vertical axis, on the vertical axis, 10 lines represent what? 20 units. So 1 line is going to be what? Divide both sides by 10. 1 line is going to be 2. So every line on the vertical axis means 2 cm. Means 2 units, just 2. At the same time, on the horizontal axis, if you do not understand what I mean at this point, because there are some people that may still not understand, please ask questions, because this is the most important aspect of our graph. 20 lines on the horizontal axis means what? 0.1. That means one line is going to be 0.1 divided by 20. I am stating them in a mathematical form like this so that it will not be as if I'm just manipulating. 0.1 divided by 20. Okay, let's find. I think it's going to be 0.005. 0.05. 0.005. That's correct. That is the value of the smallest line. That is, every one line on the horizontal axis is going to be that. So remember what you have. Now, if I have one line means two lines, 5 lines is going to be means 10. So if I add that to 40, I'm going to have 50 at the middle. 50 is at the middle. At the middle between 40 and 60, because it's 10 lines from 40 that will give you 50. If you count 10 small lines from 40, you get 50, because 2 into 5 will give you 10. Now, let us find what it means on the horizontal. How many lines on the horizontal is going to give me? That's 0.05. 18 lines of the in the horizontal axis is going to give me 0.09. So that if I add 0.3 to 0.09, I'm going to have 0.39. So that I'll be plotting 39 on the 18th line from the from this 0.3. If you count 18th line, that is where you find 0.39, because small thing before you get to 0.4. I will trace where they coincide with 70. I will count 70. 70 is 5 lines from 60. If I count up from 60, I will have 5 lines from 60 to give me 70, and that is where I'm going to mark the line between 0.39 and that of 70. Let's go to the next one. So I am going to be plotting for 0.46. What will I do to 0.4 to get 0.46 under 90? From 0.4 to what will give me 0.46? Let's count now. If I say at the middle of 0.4 and 0.5, will it give me 0.46? Let me guess. Which number will I multiply by? Each line on the horizontal axis means 0.005. How many times of this 0.005 will give me a number such that when let's say 0.05 times 12. Yes, it will give me 0.06. Yes. Then if I add this 0.06 to 0.4, I will get 0.46. Good. From 0.4, 12th line will give me 0.46. Correct. Now let me go to 0.4, 12th line. After this one, 2 lines from there. That will be 12th line. Let me trace it. And I will trace it to 90th line. 90 is 5 lines from 80 will give me 90. Then I will find the coordinates there and record it. Let's keep tracing. Okay, let's plot the next one, which is going to be 0.52 under 110. Okay, sorry, that should be 0.46. 0.46 under 90. Let's finish marking it out. You need to take that decision, very, very important, before you mark your point. so that you will not make mistake. So that is the point. That is the point at that is 0.46. Because I'm not plotting all the 4 decimal places at the same time, so I'm plotting to the 2 decimal places. So that is the line. Let's move to the next one. Let's clean up first. Okay, let's go to the next one, which is 0.492. 0.492. Let's say how we are going to find that one. How many 0.05 times how many lines will give me 0.49? Let's say 15. Can 15 help us? No. 15 cannot. I need to get 0.09 so that when I add 0.4, I can have 0.49. So it should be 18 lines. 0.05 times 18. That should give me 0.09. Yes, add it, multiply. 0.09, correct. So when I add 0.4 added to 0.09, I will have 0.49. So 18 lines from 0.4 can give me the 0.49 that I want to plot on this graph. So let me count. Let's go very close to 5 and remove 2 lines from 5. From 0.5, 2 lines out of 0.5 will be located to 110. And 110 is 5 lines from 10. That would be what is going to be correct. And I think that point is shifting away. I'm going to have some headache in my line of base fit. Remember, line of base fit is going to be very important when I'm going to be drawing my straight line. So you need to pay attention and watch till the end before you be able to know that. All right, let's go to the other point we are going to plot. The next point. Let's clean up first. Let's clean it very well. I think I'll plot in 0.52. Think 0.52. How many lines from 0.5 will give me 0.52? Or am I plotting 0.5? Let me check according to our table of values. Okay, let's go to the last one, which is 0.506. So I'm going to be plotting 0.51 because I'm going to run this up to the 2 decimal places, and that's what. Okay, 2 lines from 0.5 will give me 0.51. Add it to 0.5. I'm going to have 0.51, and that means 2 lines from 0.5 will give me 0.51, and I'll try to go back to 0.5, and then 2 lines from 0.5, which is close to, which is coordinated to 0. Okay, that should be under 130. Should be under 130. So let me locate it very well. Okay, under 130. Thank you. I think I am done with the plotting. The next thing I'm going to show us is, let me clean first. Before I show you, the next thing is going to be my line of base fit. So clean very well. Okay, let's check the line of base fit, because the thing is trying to show curving line, but that's not correct. Line of best fit. Please, it's very good you support our channel. It's very important. You can also join to learn more. If you want to learn more, you can join. Go to my profile on the YouTube profile, you join. You can also follow us on VINDAL'S Academy on TikTok, VINDAL'S Academy on Facebook, and VINDAL'S Academy on Instagram. So let's go to line of base fit. Let me show you how the line of base fit is going to be. Let me use a different color. I'm going to be drawing different lines that may likely happen here, but at the end I will show you the line that is best fit. Look at this. Do you think this is the best line? The line is not even starting from, did not cut any axis. That's wrong. That's a very wrong way of drawing line. So you must draw from a particular axis. Choosing this line, is it the best line, the line of best fit? I don't think so. I would not like to use, this is not the best line of fit. Even though two lines fall out of this side and two lines fall out of the other part, but I won't choose it as my line of two lines out here, the other line at the other side. So it kind of balanced, but I will try to ensure that at least 2 or 3 points enter my straight line. Why choosing my line of base fit? That would be better than choosing just 1 point. So let me see if that can be achieved. Let me keep trying. Let me keep trying to see if I will get a better straight line, which is called the line of base fit. Let's keep going, okay? Okay, like I said, let's remove that line and try to draw another line. Let's check this part to see if I can call it the line of best fit. No, 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 no. Remember, this cannot work. No, this is not good enough. This can never be the line of best fit because 3 points are falling on one side and 1 point is falling on the other side. So let's not use that one. Let me try something like this. Yes, let's see if we can go that part. At this point, 1 point is falling out of this, 2 points fall out of this. No, 3 points are falling out of, 2 points are falling out of one side of the line. It cannot work. Let's see not use this one. This is not the line of best fit. Let's try another line. Just be patient. Let me show you what the line of best fit. Okay, if I choose this line, you see 2 points are falling out of the line. 3 points are entering, but 2 points are falling out of the line. It can never be the line of best fit. So I will not accept this. This is wrong. Okay, now I have shown you different aspects of the line. It is time for me to show you the best line of fit or line of best fit. Okay, let me take it this way. All right, this is the line of best fit I want to show you right now. So pay attention. Yeah. And at this point, I have to make this decision that two lines are entering. Now, if you check it very well, you realize that 1 point fall at this side, 1 point fall at the other side, then 1 point fall at the other side. Look at the 3 points that did not enter the line, they fall side by side. One this side, one the other side, and one the other side. So this is my line of best fit. I don't know what you have to say about this. Probably you have to comment uh, on this, but this is what I've chosen. So the next thing I'm going to do is to choose my slope. I have to make sure that my triangle is very big. When you have a very large triangle, you are going to make some points. You're going to make a very point, like maybe half mark or 1 mark for making a very big triangle. Don't make your triangle to be small. So I'm choosing any point. I'm choosing that particular point there. It enters into the line, even though it's not part of the point I plotted, but I can just choose any point that enters the straight line because any point that enters the straight line obeys the graph I have just plotted. So I will also make angle 90, I mean a triangle, a right angle triangle with the 2 points of my choice. From there, I will take my slope. All right, this is my triangle. That's angle 90. So my slope is going to be, I'll choose change in mg change in mass all over change in y all over AO. So I'm choosing the point. You know, all right. So now the first one is 130 minus 18. Then if you go to the x-axis, that is going to be 49. I think 049. 049 minus, I think 0.25, because from here trace it down to the x-axis, or 0.24. You know, you need to make that choice very hard. You need to make the choice very properly. 0.25, correct? And we are going to do our subtraction. 130 minus 18, 112. Then 0.49 minus 0.25 is going to be 0.22, 0.24, correct? And 112, and slope is going to be 112 divided by 0.24. And we are going to have 466.67. The slope is, the unit is going to be grams. Yeah. That is the slope for this kind of graph that I plotted. Remember, I'm plotting mg against y over AO. A question may also say plot y over AO against mg, but I just decided to plot mg against y over AO. And this is